Okay, so now we're going to look at a couple of examples based on what we have discussed in the previous video. So as you can see, these are several questions, actually 4 questions. So we're going to do each in turn, all right? So the first question is asking for the mass of 0.0750 moles of a sample of sodium. So what I'm going to do is get out of this, go to my writing application here, get rid of that. Okay, so in this question, you're given 0.0750 moles of sodium, and you're asked to determine the equivalent amount expressed in grams for the same substance, right? So the first thing I would do is go to the periodic table and look up the molar mass of sodium. The molar mass of sodium, if you look it up, would be equal to 22.99 grams per mole. So the way I would set this up is that I would start off with the information that we're given, which is the moles of sodium. And then I'll multiply by a conversion factor, which represents this number right here. The question, of course, becomes what goes up top here as a numerator and what goes down here as the denominator. And because you want to get rid of the mole unit, then I would put 1 mole of sodium below and the molar mass above, which is 22.99 grams. And then I would work that out. So 0.0750 multiplied by 22.99. And according to my calculations, that works out to be equal to 1.72 moles. So 1.72 moles, I'm sorry, not moles, grams of sodium. Because this mole unit of sodium here will cancel out this mole of sodium, so that would be the remaining unit. All right. Excuse me. So that's a relatively simple example. All right. So let's look at the next question, which says you're to calculate the number of moles of sodium in a 62.5 gram sample. So this one is kind of reverse of what we did in A, because in the case of A, they gave us the moles and they're asking for the mass. In this case, they gave us the mass and they're asking for the moles. So let me go back to this right here. I guess I can do this problem down here. So in this case, you're given 62.5 grams of sodium, and you're asked to calculate the equivalent amount of moles of sodium, all right? So again, we start off with what we're given. Oops. And then I'm going to multiply this by a conversion factor, which again represent this. But in this case, because I want the grams of sodium unit to cancel out, I'm going to put 22.99 grams of sodium down, sorry about that, sodium down here, and 1 mole of the same above. And I would work that out. So 62.5 divided by 22.99. And the answer I got here is rounded off to 3 sig figs would be 2.72 moles of sodium. All right. And that's basically how that is done. All right. So as I said before, it's kind of like the reverse of what was done in the previous A part, right? Okay. Let's go back to this. And now this question is asking, the C part is asking the mass of a sample of sodium containing 1.00 times 10 to the 25 sodium atoms. All right. So let me go back to this. I think I'm going to remove all of this here. Page. Okay. So in this case, you are given 1.00 times 10 to the 25 sodium atoms, and you are to determine the amount of sodium in grams, so grams of sodium, all right? Now in this case, you have to take a two-step approach because you're given a number of atoms of sodium and you're asked to find the grams of sodium. Now we know that we can determine, based on the number of atoms of sodium, we can determine the moles, right? Using Avogadro's number. So here we would use Avogadro's number to do that conversion. And then we can find out the equivalent mass in grams of sodium. In this case, we would be using the molar mass. So in order to solve these problems, we're going to need two conversion factors in series, right? One to convert from the number of atoms of sodium to the moles of sodium, and then the other one to convert from moles of sodium to the mass in grams of sodium. So we're going to start with what we're given to begin with, 1.00 times 10 to the 25 sodium atoms. And we're going to multiply by a conversion factor, as I said before, which allows us to convert from the number of sodium atoms to the moles of sodium atoms, right? So therefore, the conversion factor that you have here will have, oh, this should be sodium atoms here. So up here, you're going to have moles of sodium, and down here, you're going to have sodium atoms, all right? So the question now becomes, what would be the numbers that would go at top and below? Below here, you're going to have Avogadro's number, 6.02 times 10 to the 23. And up top here, you're going to have 1 mole of sodium atoms, all right? So that's the arrangement. This will cancel out with this. So the only unit remaining would be the moles of sodium. So we would have completed the first step. The next step is where we convert from moles of sodium, scratch this out here, convert from moles of sodium to grams of sodium. And that's where the molar mass comes in. So basically, you're going to have grams of sodium above as the numerator and moles of sodium below. So the question now becomes, what goes up here and what goes down here? And because the molar mass is the mass in grams per mole of the substance, we're going to put 1 mole of sodium here and the molar mass of sodium above, which, as we said before, is equal to 22.99 grams. And then we do our number crunching, 1.00 times 10 to the 25 divided by 6.02 times 10 to the 23. Then we multiply by 22.99. And the answer I got is equal to 382 grams of sodium. And that's how, let me do this again just to make sure I have it right. 1.00, whoops, 1.00 times 10 to the 25 divided by 6.02 times 10 to the 23 times 22.99. Okay, so that's the answer, 382 grams of sodium. Excuse me, all right? Okay, so that's basically how the C part is done. And then finally, in the D part, the question is asking for the mass of a single sodium atom. The mass of a single sodium atom. Okay, so let me remove this here. Okay, so the question is asking for the mass of a single sodium atom. Okay, so we know that the molar mass of sodium, coming directly from the periodic table, is 22, I'm sorry, not the molar mass, the atomic mass, coming directly from the periodic table, would be 22.99 AMU. All right. In fact, I made a mistake here. This should be molar mass. I should be doing the molar mass. So let me erase this here and replace that with the molar mass. All right, so go back to this. So this should be molar mass. In which case, the units, let me erase this here, would be grams per mole. All right, grams per mole. All right. And we know also that Avogadro's number, Avogadro's number is equal to 6.02 times 10 to the 23 moles to the minus 1. All right. So the question now becomes, if this is the mass of sodium for 1 mole, and this is the number of atoms of sodium in 1 mole of the substance, then to find the mass of 1 sodium atom, that will be equal to 22.99 grams per mole divided by 6.02 times 10 to the 23 atoms per mole. The mole units will cancel out. So basically your final answer would be the mass, the unit of grams per atom. So let's do that calculation. That would be 22.99 divided by 6.02 times 10 to the 23. So according to my calculations, this works out to be equal to 3.82 times 10 to the minus 23 times 10 to the minus 23 grams per atom. All right. Okay, so that's basically how we do these examples. All right. Okay, so the next video that I'll be posting will deal with this concept of mass percent composition from chemical formulas and other things as well. We're going to be talking about empirical formulas derived from mass percent composition data and some other things. Again, a lot of this would be review for you guys based on what you did in introductory chemistry or high school chemistry. All right, so we're going to stop here for now, and then we'll move on to this topic in the next video.